There we go. Yeah, cool. All right. Nice clickbaity title, right? I guess that's why you're all here. Hi, I'm Hannes. I'm going to start with a small service announcement. Today at 12, well, at least between 11:55 and 12:10, the Norwegian government is going to test their alert system, which means that any phone connected to 4G or 5G is going to sound a siren-like alarm, and it's going to give you a pop-up on your screen that you have to swipe away or OK. Okay? So that's going to happen. It's going to happen during this talk. Okay? And I hate being interrupted. So, if your alarm goes off, you owe me a beer. Right? Can we play that game? Now, the thing is, we're in Norway, so a beer means you have to remortgage your house. So nobody wants that. Put your phones on airplane mode, turn them completely off, so that we can have this talk in peace. Thank you so much. Oh, I don't think I've turned mine off, actually. So let's do that. There we go. So, clickbait. Clickbait is content with the only purpose of making you follow a link so that they can get more ad revenue on their website, right? You came to a clickbait talk. Now, what does clickbait usually say about the content? The content isn't all that shocking. It's a total waste of time, which means you have been warned. You can still walk out and go to another talk. So let's go. I'm Hannes. I have 3 beautiful children, and I recently got engaged to my partner of 18 years. I am the league coach.net at Access, which basically means Hannes does whatever he wants. And I have been a .NET backend developer for a very long time. I play with Dylan Beatty and the Linebreakers. Those of you who don't know what that is, in this venue, tomorrow evening, our horn player is sitting right here as well. And I get some community recognitions from Microsoft and Service Bus. Now, I have a plan for today, and I have to say, I am scared shitless. I've never done a live coding talk before at a conference. But that's what today is going to be. So first of all, I'm going to present you 10 features that Entity Framework has that are either semi-recent or really surprising. And I will tell you what they do without showing you code. And then I will allow you to vote. You can take out your phones. Oh man, if that coincides with the alarm, that's going to be interesting. I only just realized that that may be a problem. But you can scan a QR code and vote for the ones that you want to see the most. And then I will work my way down the list until the time is up. And then we all get lunch. Which means that you have to stay awake through this part until the vote. During the coding, you can take your nap, and then there is lunch. Right? That's the plan. So here we go. I have 10 in no particular order, and I'm just going to tell you what they do. You listen. It's just a bunch of hand-drawn slides. And if you think that that is interesting, you remember it, and you vote for it when we get to the end of the 10 features. So, on the code side, we often have more complex models than just a DTO. So what I've done is, on the left, I've put all the things that happen in the C# code. On the right, I've put all the stuff that happens in the database. Now, what we have is we often have nested classes and a lot of nested models. And if we start putting that into a database and we don't do any configuration, that all becomes separate tables, and it's very complex. You have to do a lot of joins. Now, we had own types for a while in EF Core, but behind the scenes, Entity Framework still reasons about own types as having an ID, and it has a whole bunch of implications in runtime. Now, in the last version of EF Core, what we have gotten is the ability to do those own types, but behind the scenes, they are no longer defined by an identifier. They're defined by their values, which makes it a lot easier to map things like value types in your domain. So that's a pretty nifty feature. So we can take out a part of our model and just push that into a bunch of columns in the same table. You won't have to do any joins. It's going to be much faster. Also, behind the scenes, there is no ID shenanigans going on. Right? Value type properties. Many-to-many relationships. It's something we often have to do. Right? And if you don't know how to model them, What you have is you can have many of entity 2 for entity 1 and the other way around. If you model this in your database, what you'll have is you'll have your two tables with a primary key, and you will make a join table. And that join table has two foreign keys pointing at the two primary keys of our two tables. And that combined will be the primary key of that join table. And that's how we define that many-to-many relationship, because we can only link each entity to each entity once. Now we can do the same thing in Entity Framework. You can have the two entities, and you can have like a joint entity in between, but what's the fun in that? What I want is to have two collections in my two entities, and I don't want to see that join table in my model. I just want them to point straight at each other in code, because that's much easier to reason about. It represents the intent of what I'm doing a lot better. And I'm not seeing that join entity, so I don't also have to do includes that are 2 levels deep. It's a great feature, and you can do this perfectly with EF Core. And then hierarchies. Hierarchies are amazing. We often model things that look like this, like a tree of data, right? And if you don't know about this feature, you will probably end up modeling it like this. You will have a foreign key in your table that points at its own primary key. It points at its parent. And that way you can model that entire tree in your code. But the problem with that is if you have to do complex queries, like get all the descendants for a certain item, that becomes pretty annoying. Now, SQL Server has a feature for this. It has a feature called Hierarchy ID. It's a feature of SQL Server where you can basically have your hierarchy location in a single field, and that allows you to do way more complex queries. So that when we do this with any framework, we can have a query that says, hey, give me all the descendants of this one tree item, or give me all the parents that go up the tree from a certain location. That sort of queries is a sort of queries you can do with hierarchy IDs. And in your tree structures, that is a lot more efficient to work with than it would be to have that self-referencing foreign key. So that got introduced semi-recently, and that is, I think, a very nifty feature when you're modeling this type of structures in your data. Now, we've all had Dapper for a very long time, running raw SQL queries. So what we want to do is we have this string literal that we push some parameters into, and then we run that on the database, and that magically rematerializes as objects when we run it. And basically, all Entity Framework has done, it has stolen that idea from Dapper, right? First version was a little bit slower than Dapper. We're getting pretty close at the moment. So basically, what you're able to do is you can run your SQL query literal against a DB context, execute it on your database, and return a bunch of objects to your code. Very nifty for those situations where you have a query that is either too complex to express in LINQ, or where you want to use SQL Server specific functionality in your query that you cannot properly express in LINQ either. Sometimes it's a performance issue. If you don't want any parsing on the LINQ to happen and you don't want any change tracking to happen, this can also be a way to do it, but there are other ways to get that behavior in Entity Framework as well. Similar to the first one that I explained, you sometimes want to just push a more complex field into a JSON column, instead of just pushing it into a whole bunch of separate fields in your database. So what you can do is, in your table, this is my record, I want to put that nested object into just a field that is represented as JSON. This is nifty for those situations where it is actually really complex and nested, and it would end up being a lot of fields, or it's hard to represent because there are collections in there. And if you want to do collections with own types, you will end up with join tables and so on. But in JSON, you won't have to. In JSON, you can say, OK, put all of this into that JSON column, and then you have your whole collection of nested data in a single string in your database. Fantastic. Now, one of the performance issues that you may run into when you're using Entity Framework is how queries are batched towards the database. And I don't know if you know this, But when you have a DB context, that part you probably know, it acts as a unit of work. And you're queuing a bunch of statements that need to get executed as soon as you hit the save changes. And as soon as you hit the save changes, all of those statements are executed in a single transaction, so you get nice consistency. But it could end up being a lot of round trips to your database, and round trips are expensive. You're going over the network, you're going to another system, right? So that could be painful for performance. So what Entity Framework does behind the scenes, it takes batches. It takes a whole batch of queries that happen in one go, and it sends all those statements in one round trip to the database, and you have control over that batch size if you want to. Fun fact, the default batch size is 42. There's reasons for that. I will tell you those reasons if you pick this one. Now, inheritance is probably one of my favorite Entity Framework features, and it has been there for a long time. This is nothing new. But if you have inheritance in your code, you have a parent entity, and then you have a couple of inheriting entities that, and you go further down the tree. And on the database side, there are a couple of ways of modeling this. You can either take the default way of doing this, and that is just have one big table for all of the fields. That means that you're going to put the parent fields next to the child fields, and they all go into the same table with a single primary key, and you will have one column that is the discriminator, which tells you which type of data is in that particular record. So Entity Framework queries this table, and it looks at the discriminator, and that tells you what it should deserialize this row as. So that means that if you have a vehicle table, that could tell you that a car should be coming out or a boat should be coming out, and it will actually pick those properties that it needs to give you back the correct type. And that saves you a whole lot of hassle, because you can have a single DB set for the parent entity, and you get the correct runtime types back when you query the data. Now, table per hierarchy is what this one is called. It's not the only way of mapping this in the database. There are other strategies as well. You can do table per type. Table per type means I have one table for the parent entity, and then further down the tree, we get tables for each child entity. And each child entity has a primary key that is also a foreign key that points up towards the parent, which means that all the parent fields live in the parent table, that all the child fields live in the child tables, and everything looks in the database the same way that it looks in your code. It's easy to reason about as a developer. The downside of this is you'll be doing a lot of joins when you're querying this. You also don't have a discriminator column, so you're joining all the tables and just looking at where you have records, right? That's what Entity Framework does for you. You don't have to do it yourself. Table per type. There is a third strategy, and that one was only recently brought over from EF6 into EF Core, and that is called table per concrete class. You will have a separate table for each entity, but we will repeat the parent properties in the child tables, so that to get a record out of those, we don't have to do any joins, we only have to union across those tables, so that's a good thing. The bad thing about this is that you sacrifice something very important, because we can get away with having unique primary keys across all of those tables by using a sequence on the database side. But what we lose is the ability to have a foreign key point at the correct entity, because the entity is spread across many tables. Your records may be in the child 1 table, but you want to put a foreign key towards the parent entity. That no longer works, right? You gain performance, you sacrifice something. There is no free lunch, right? There's lunch after this, though. And although you will not be paying for it, your employer paid for it, so there's that. So you can do all three of these strategies in Entity Framework Core. And they have been around for a long time, but they are there now, and we can have them in EF Core 8. All three of them are available. And this is a cool feature. It's a pre-release feature from EF Core 9, but I'm so excited about it, I really wanted to put it in this presentation. What Microsoft is planning to do is you will have one DB context with a bunch of DB sets in it, and you can map your DB sets to separate databases. And for now, We will only be able to do that with SQL Server, but they're planning to bring support to other database engines as well. And the cool thing about this is you will be able to do query and CRUD as a normal DB context. You will even be able to do joins across different databases. This is Microsoft's idea of the future of polyglot persistence in our projects. I'm really excited about it. It's very bare bones as it is right now, but I'm hoping that this will really take off. There's going to be some interesting stuff happening when we get this. Logical deletes. Logical deletes is also something that you can easily map with Entity Framework. It's not an Entity Framework feature, but it's something that we can really put some small things together to make it happen. So if we have a logical delete, we have a record there and we want to delete it, it normally deletes that record from the table. But instead, what if we introduce a deleted column that we set to true when we actually delete the record, so that it's not really gone from the database, but at least through the DB context, we will no longer see it. And if we combine a couple of features of Entity Framework Core, we can easily achieve this behavior. The features that we will need is first a shadow property, because we won't show the deleted field in our model. Then on that property, we will put a global query filter to make it happen that we can no longer query the records that have been deleted. Then we will have to do a save changes interceptor to see when we delete an entity, instead we modify it and we set that shadow property to true. And of course, for that, we will need the change tracker to see which records have been deleted. If you put all these things together, you can have logical deletes without too much hassle in Entity Framework Core. Compiled queries. There are some points, I mean, the basic performance tuning in Entity Framework Core is usually looking at how many queries are you executing, are they hitting the right indexes, that sort of stuff. But when you've got all of that out of the way and you have code that lives on your hot path, converting your query and the parameters into an actual SQL query can be an overhead that is worth dealing with. Now, what happens when you write a link query? That link expression tree gets parsed. There is a tree walker that actually goes down the entire query and converts the thing into a SQL query, and it executes that on the database. And then the results that come back get materialized and get given back to the calling code. Now, this parsing step is something that we can do just once. With a compiled query, we can actually do that. We parse the whole thing, and we run it again against every DB context that we want to run it again in the future. We can even have parameters for our compiled query, but it will not go through the entire idea of this is how this link syntax tree makes it into SQL. It becomes a parameterized SQL query behind the scenes, and you just pass in the new parameters and the new DB context, and it's ready to go. So this can be a performance gain for code that lives on your hot path. Also been around for a while. And then the last one, I think it's the last one. Entity Framework needs three things to work. It needs to know what your models look like. It needs to know what your code looks like. Well, the models in your code look like. It needs to know what your database tables look like. And it needs to know how to map between those two things. And those of you who have been around for a long time remember that that stuff was all in the EDMX file, right? We don't have EDMX files anymore, for the better, which is great. But that doesn't mean that Entity Framework doesn't need this info anymore. Entity Framework still needs that model to do its work. Which means that if you're developing, your first DB context is always really slow. It's because Entity Framework is building that mental model of what the code and the tables look like and how to map between them. And nowadays, luckily, we feed that info either with conventions in our code or with mapping expressions in Fluent API, but it still builds that model. It's why some developers have the feeling that Entity Framework Core is really slow, because as developers, what we do is we hit F5, we hit that first initialization. Who owes me a beer? Is it time yet? Yes. Anybody owe me a beer? Damn it. So it still needs that mental model. But it doesn't need that model at compile time. It builds that model at runtime. which means that we can influence that model at runtime as well. So in theory, what you could do is you could have a DB context that has no DB sets, and you feed it a bunch of info in the on-model creating, and you can use that to actually have all that info in the mental model that the DB context is going to use. So it will know about the tables, it will know about the code, and we can actually use that to do stuff with a DB context even though we don't have DB sets. Because it derives the DB schema from the stuff that you give it, which means that we can save entities and query entities and all that without even having a single DB set in our DB context, right? And I don't recommend using Entity Framework Core this way, but it does come in handy when you're doing flexible stuff where you need to tell it about inherited entities that live in plugins, for instance. I mean, in those scenarios, you could have a use for this type of functionality. And I just want to make you aware of how Entity Framework builds that model. And I'm really scared now, because we're getting to the voting part. And it is around the time where all the alarms are going off. But you're going to need your network connection to do this. Now, there is a twist. There is a twist. I have presented 11 things, and one of them is fake, right? So we're going to play another game, apart from the beer game, because I've lost that, and I want to win. I will code the things in order that you vote them. But if I make my way to the fake one, I win, right? So don't vote for the one that you think is fake. That is the whole thing. I will tell you at the end which one the fake one is. If you scan that QR code, you should be able to vote. You can just drag some items up, and when you're done and you have them in the order that you care about, you can press submit, and we should hopefully see this slide move as we go. Oh, that's good. We have participants ranking. That is JSON columns, right? You can vote for more than one, by the way. You can drag up as many as you want. Okay. That seems to be stabilizing. There's 21 people still ranking. I'm going to let that get down to 5 or something, and then we'll get going. There's new people coming in. Oh. This is actually a great way for me to count my audience. That's like more than 150 people in this room. Thank you so much for coming. I'm going to take a picture so I know which order we have to do them in. I'm not sure if I can get back. I will keep the voting open. And this is the scary part. This is the first ever conference talk where I do live coding, and it's the first conference I'm doing it at. So let's see what happens, right? I am prepared though, so it should be fine. Should be fine. Here we go. I have a solution with all of the demos. I'll take a look at what was top of the line, and that was JSON columns. Right. Okay. The JSON columns demo, I can already tell you that was not the fake one, so that's good. You did good. Did you vote safely and you don't care about JSON columns, but you're sure that that is something that exists? Is that the game you're playing? Could be, right? Okay, cool. What we have here is I've made a DB context, and wow, this is so annoying. Thank you, Norwegian government. I reckon the government owes me a beer, right? I can just walk into Vinmonopolet and ask for one, or how does that work? So what I did here is I have a shipment, and my shipment has a shipping label, and my shipping label has a shipping address. So I'm nested a few levels deep, right, to represent really what the use would be of doing one of those JSON columns. And all the mapping I have done for now is map it all as owned types, right? Owns one. And for now, if I run this code, what I've done in my program.cs, this is going to be the same for all demos, so you know a little bit what's going on. First, I call recreate database, and that just doesn't ensure delete it, ensure create it. It throws away my entire schema. So when I change things, we will be able to see the changes in the database. This is my cue to also fire up SSMS. Right, there we go. So I recreate the database, and then I'm able to create DB contexts with the correct DB context parameters. That just goes on in a function below. It doesn't do anything fancy. Do not recover. I don't need any of that. There we go. So what I have now, I'm just adding a shipment with all the data. That's all I'm doing, and I'm calling save changes. So if I now run this, and I run JSON columns, we should be able to go and take a look in our database what we are getting. That one was demo number 5. OK, that's good. So we should look at database 5. I did prepare, you know. So I get a shipments table, but it has a lot of columns, right? I should be doing this. I learned about that this week. So what we get here is we get the shipping label fields, and then we get another level down for the shipping address. If we were to do this with something that has a collection, then we would get a second table for it with the own types and so on. It gets a little bit messy. And the shape of that structure may change from time to time, so maybe I just want to dump it in a JSON column and be done with it. Now, that is exactly what we will be doing. I should be able to go back out. Yeah. OK. Cheat sheet. Come on. Oh, yeah, I changed this for line breaker friends. This is also the iPad that we use to control our digital mixer. Now, when you want to do JSON columns, you still go into the owns one syntax. So this remains an owns one, but the shipping label here is the only one we care about. We don't need this line anymore. That will be implied because it is a property on our shipping label. Now, the way that that works is there is a second parameter that we can pass into that owns one. And that is our builder to actually define how that owns one relationship is constructed in the database. So what I should be able to do, it's called the owned navigation builder. Navigation builder. I should be able to use that one to configure my thing the way that I want to have it. And actually, the easy part about it is, the first thing I will have to do is I will have to use that builder. Can I get rid of that? Yeah. And I can just say to JSON. It's simple as that. And that tells it that this own type should be dumped into a JSON column instead of dumping it into a whole bunch of separate fields and possibly even additional tables. Now, the other thing we will have to do is, as soon as we now have those nested properties, we don't put them at the top level of it anymore. We have to put them into this navigation builder. Hey, Art, how are you doing? One of the best photographers in the whole conference circuit in the world, really. So we have to tell it here that it owns another type. So we do the owns one here. And as you can see, you have syntax for owns one and owns many down this. So if you have a nested collection and you want that to go along into your JSON column, this is where you map that. So here I can just say label dot, and then I can do my shipping address, right? There we go. Now this should be it. This should be the entire mapping that I need to actually put everything into JSON. So if we now run this again, we should be able to open our database. Instead of all of those fields, we will see one column, and it should have, oh, what did I do? Requires the primary key to be defined. Oh, yeah. It has no key, but that should be fine. Oh, did I have? Oh, that is my problem then. Thank you for thinking along. That's great. This should be owns one, and then that should solve that. Talking and typing at the same time. Yes, it worked though. So if we go and look here now and we refresh the columns, we see that we now have shipping label, which is a varchar max. We can still control the size. I mean, don't worry about that. You can still do all the mapping on it the same way that you would do on a normal property. If I now select this and we take a look at what we get, this actually, I'm not sure. I'm just going to copy this and put it into a notepad or something so we can see what is actually stored in there. What we get is indeed our, can I increase the font size? I probably can. There we go. So we get our tracking code, we get our shipping address, which is nicely nested. No, this is not my home address, by the way. It is our company's address. So all of it is in there in a nice JSON document, and it will also fetch that as a nice JSON document when you're fetching this entity. And because it is an own type, it will always be fetched along with the parent entity. Right? So that's JSON columns. That's one down, right? And we have time. But I am fully aware that I'm standing between you and lunch, so I will try not to run over time here, okay? So the second one, let me look at my phone. What was that? That was many to many, wasn't it? No, hierarchical IDs. Ooh, that's a fun one. I love that one. It's new. It's also not the fake one. Yay! So we have hierarchical IDs, and I've prepared something, and I know that you are all a bunch of nerds just like me. So I think you will appreciate the domain, and I've not invented this. It is also the demo that Microsoft uses to actually do this. The demo is with hobbits. So what I'm doing here is I have all my halflings. I have the entire halfling family tree. And I just make a single DB set. And the hierarchy ID is actually the hierarchy from the original patriarch. So the original top level node of my entire tree, and then that ID gets defined. Now it becomes more clear if I show you, I have a link here, should be there, because in the recreate database, I'm actually inserting all of the halflings. But to show you what's going on, I should be able to open that. So we have this entire tree, and you can see the IDs on this. So you have Balbo is at the top of the whole thing. He is the root halfling, right? And then we have the second level. You get /1/ and 2 and 3 and 4 and 5. And the further down the tree we go, the more nodes are added to the ID. And the advantage of doing all of this is that you can do queries on the ID and get the part of the tree that you're interested in compared to the node where you are, which is a lot more powerful than having that key. Now, the way that this will work, because I've already inserted the data, and I'm going to show you the bits that you need to do it yourself, but this would have been way too much to live code, so I've prepared it. But we will still do some live coding with this. So hierarchy ID is something that comes out of an Entity Framework Core package that actually enables this. So the hierarchy ID is living in the SQL Server .hierarchy ID package. So if you want to use SQL Server's hierarchy ID features, you need to enable that package. And that gives you this class. And hierarchy ID can just parse from a string, and then it will be able to deal with that. If we put it into our database, that comes an actual hierarchy ID column. Now, if we insert all of these halflings, that gives us a database that we can play with. So for now, I'm just going to print them all out to show that this works and to show that we can take a look at the database. And then I will show you a little bit how you can query this and why this is way more fun than having self-referencing primary keys. So It is my startup project already, so it should be good. And of course, the entity type hierarchy, what did I do wrong? The entity type hierarchy ID requires a primary key to be defined. Yay! That should work. Oh no, it should not work. I know why it's not working. Okay. Hierarchy IDs need to be enabled on the DB context. So I need to go down here. And when you do the use SQL server, that is where we enable the hierarchy ID. So when we do our connection string, we can basically use, again, some kind of options builder. And on the options on SQL Server, I was scared for a second. I can do options.use hierarchy ID, which will enable the feature for my DB context. And I'm just going to rerun and see what happens. And that should solve my problem. And I should have my halflings in my database. That looks way better. So that was database number 3. It should print them all out, by the way. But it's inserting a lot. Maybe I should control the batch size, right? So they're all there. And I can take a look at that database and see what we have gotten. So this is the one. And I have my halflings there. And the columns that we're getting is, let me get the magnifier again. So the columns that we're getting is we get an ID, we get the pet from patriarch, and you can clearly see that we have the hierarchy ID there, right? And then the name and the year of birth, as expected. Now, what that looks like if I select all the rows, they're stored in SQL Server in a different format than the one that we're seeing in code. It does not really matter. You do see the nodes get longer as we go further down, and that means that we're adding additional bytes to define the IDs, right? So the IDs are there, so this works. Now, how can we query this? Why is this interesting? Well, POSCO lives somewhere midway in the tree, on the 3rd level. So that means that from him we can go down or we can go up. And those are queries that with self-referencing primary keys would actually be very hard to do. It's easy to do for one level. It's hard to do to get the entire tree, because that usually requires recurring calls or very, very, very complex SQL queries. So this enables all of that in a heartbeat. So I can just do a where here. And if I just take my halfling, I can do, halfling. What I can do is I can do the pet from patriarch, which is my hierarchy ID, and I can say is descendant of, and I can pass in my ID, and my ID of POSCO is already constructed above. And this query actually gets parsed towards the database and is executed there, and will return only the part of the tree. We can take a look. I still have that open, don't I? So he's sitting right, that's not him. He's sitting right here. So we should get him and 4 child nodes, right? So that's what my code should be doing, 2 levels down. If it all works, that is what we should be seeing here. I'm gonna move my magnifier around. And yeah, this is the downside of the whole ensure deleted, ensure created. It always takes a little while for the bigger demos to load. But there they are. Now this is really cool because we can also go up the tree with a single query. And we need the same syntax, we just need to flip this to the halfling, right? Move that one to the other side. So the query works in 2 directions. What have I done? Oh no, POSCO is descendant of, and then I need to do halfling.pat from patriarch ID. So that allows my query to go in the opposite direction, and now I should get all the nodes that go up from POSCO. And there's a little bit more to it. We can also get the level in the hierarchy of a certain node. So the parent. There is a bunch more methods that we can get on those IDs, but we go all the way back up to Balbo, right? So this is super convenient if you ever need to model those trees again. Do you have a question?
Because the hierarchy ID is just a column,
Yes.
you could have multiple hierarchies on the same set of objects.
Yes. Okay, I'm going to repeat the question because none of you have heard that. Because the hierarchy ID is just a column, you can have multiple hierarchies on the same entity. The answer to that is totally yes, right? This is just a column. Yes, this is nice. If you want to structure data in tree-shaped structures, hierarchies and IDs are amazing. I was really hoping that I would be able to do this demo, so thank you for voting for it, as it's a nice one. So if we look at the syntax of this hierarchy ID, we can see, I'm not going to run it again, don't worry, you won't have to wait for it. But you can see there is things like a get level. You can get descendants, get ancestors, that sort of thing, and then you can get hierarchy IDs that are working with the stuff that you need. Get level, in this case, will return tree for POSCO. I'm just not going to play with that anymore, but you get the idea of what the power of this thing can be. Next one you voted was, I think, many-to-manys. Yes, many-to-manys. That was a fake one. No, it wasn't. Many-to-manys are... let me set that as my startup project. There we go. Yes, question? There's too much noise downstairs. I don't really hear you. Wait, can you? I know, yeah. The is descendant of always includes the root node. That is how it behaves. But if you exclude the ones where the level is the same, okay, now you're going to have to make me rerun this. But that's not a problem. What you could do, if you want to exclude that node, you can play around with the other functionality of the hierarchy ID. So what you can do is you can go and POSCO.level doesn't equal the halfling dot hierarchy ID, the path from patriarch dot level.
Do you need to do POSCO path from patriarch get level?
No, because POSCO is already an hierarchy ID, and path from patriarch is my property on the entity. So if I do this, I will not be including him in the hierarchy. But by default, you get the node that you're starting from along with the query. That's just how it works. But now, oh yeah, I switched my startup project, right, didn't I? No worries. What could go wrong live coding a conference talk, right? A wise man once told me, if the demo goes well, it could have been a video. If the demo goes wrong, it should have been a video. And here is me taking that advice and putting it to the side, right? But I'm still having fun. Are you having fun? I'm having a good day. I'll be full of adrenaline for my lunch break. So yeah, now he's gone, right? Is that okay? So, many-to-many. That should be a quick one. What we have here is I have movies and actors and cast members. This is the way you would model it in your database. So the way it looks like is we have a movie, we have a navigation property to the cast members, we have an actor, we have a navigation property to the cast members, and then we have the join entity, which has a primary key on both of those properties. It has foreign keys towards the two entities, and it has navigation properties in both directions. This is how to query. If you want to get the actors for a movie, you're always doing includes two levels deep. And although in the database we don't have another option to model this, in Entity Framework we do. So what I'm going to do is I'm going to first run this to make sure that it works, just to see that we get what we do. Startup, no, not that one. Good. So if we run this, we will get the tables as we expect to see them. This gives away a little bit about the movies that we have. So let's take a look. That was demo number 2 at the tables that we're getting. Just getting those in. And as you can see, we have actors, cast members, and movies. So we expect that that is the database structure that we are dealing with. Now, I want to get rid of that. This needs to go from my code. And what I'm doing here in my program.cs is I'm taking 2 movies and 2 actors, and I had to look for some actors I like that have been in the same movie twice. Now, Robert De Niro and Al Pacino haven't been in a bunch of movies together, not just these 2. But they have been in a bunch of movies together, which means I could map the entities in 2 directions and just add everything to my database. Now, I don't want to be doing this anymore. I also want to change the code in the context to not have this entity. So I'm just throwing this away. So that needs to go, which means that I can no longer point at cast members. Well, what I can do is here I'm going to point at actors. So that should be actor. I'm just going to call this collection the cast. And of course, that should be initialized as the correct type of collection. The same here. I will do movie. Was in movies, something like this. And that will be a movie as well. Now, in order to map this, this entity no longer exists. Now we have to set up that many-to-many relationship. By default, I think it will do some of it, but we could control a lot of what is going on. And my iPad got locked again. No worries. So when you map this, I'm going to override the onModel creating. You should never put your mapping code directly in the onModel creating. Okay, I'm doing this for demo purposes. You should be making identity type configurations for all of your types. Okay, let that be a warning to all of you. What I'm just going to do here is I'm just going to take one of the entities. I'm going to start from the movie side. That seems to make the most sense. Entity movie, and then I'm going to be able to do a has many. And the has many will be my navigation property from my movie to my actors. So movie.cast. And then instead of doing a with one, I can do a with many. And then I'm going to go back from the actor towards the movies. Was in movies. Now that I have those available to me, I can basically control what that join table looks like, because the default will just create something and this will work. But we can basically have full control over what that middle entity looks like in our database without ever showing it in the model. So I can do using entity, and using entity in this case means that I can just call this table whatever I want in the database. And we used to call it cast members. So I'm going to call it something else now. I'm just going to call it cast so that we know that we regenerated the database, right? If we see a table called cast, that is what we wanted to see. And then I'm able to control the rest of it as well. And as you can see from the signature of this, we will be having a left mapping function, a right mapping function, and then we can basically have a foreign key on that as well. So let's start from the left. And on the left side, we can basically say that our center entity has a foreign key towards the entity that we're coming from. So what I can do is the has one. And has one in this case, I will have to tell the type of, because I don't have navigation properties. This is not a model that exists in my database. So I can just do type of movie, which puts movie on the left of my relationship. It has one movie, and I can do a with many on that. So this is just mapping on that center entity. What am I doing wrong? That should be there, with many. And I will have many on the other side of the relationship. It already knows what it is, so I don't have to define that. And I can basically do the foreign key on there, meaning that I can give that foreign key whatever name I want to give it. Let's say that we call it movie ID. right? Now I can do the same for the right side. I'm not going to repeat everything. I'm going to duplicate that line and just change the things that need changing. So on the right side, I do the same thing. It has one actor. And I also have a with many, and that should get obviously a different name that is called actor ID. Now, if I want to define the primary key for this join entity, I can do that as well, meaning that the last mapping expression we get is the mapping that we do on the central entity and not on the left and the right side relationships. So how that works is I can just do the join entity in this case, and we do j dot has primary key or has key. Yeah. And I'm going to pass in my two IDs right there, right? So I'm just going to say the primary key of this entity is movie ID and actor ID. We can control this way further than I have right now. But this basically is the basics of what we had before we ran this, except it's no longer called cast member. It is now called cast. It should all work. I do have to adjust my program code here because, well, the cast member here does not exist anymore. So what I'm going to do is to just make this simple. I'm going to say that heat, and I can access this from either side really. On my movie, I can just say that my cast, well, my cast equals, and I just do a new hash set, or I can just do a new collection, right? And that will be Robert De Niro and Al Pacino. And that is not the right type. Oh, it's a non. Oh, yeah, I've been doing it wrong, aren't I? That's my brain messing up. Like this should work. No. It's just my fat fingers. It's nothing wrong with for the rest of it. So I can do this on both of the movies, meaning that I'm adding all of the actors to all of the movies, which is exactly what my code was supposed to do. We can throw away this now. And it also means that now my includes become a lot easier because I can just say include movie.cast. I only have a one level of includes, and it will query everything correctly for each cast member in movie.cast. And I don't have this extra level, so I'm simplifying all of my code. And the reason that I put all of that in there is to see how much simpler the many-to-manys are if you map them correctly. So if we run this, this should work. We should get our movie. It should be in the database. We should see a table called cast. The skip navigation was in movies, doesn't have a foreign key associated with it. What have I done wrong? Probably something. Oh. Yeah, I should have done principal keys as well, right? I totally forgot about those. No worries. I can get this fixed before lunchtime. What I forgot here is that this mapping entity also requires a principal key, so I'm just going to do this dot has principal key. Now it becomes a mapping issue. The code is done. We've simplified that. Now we have to make sure that it is mapped correctly. And my principal key in this type, in this thing is we do name of, because we also don't have lambdas here because we're in this weird limbo. Movie.id. And I'm going to have to do the same for this one. And that should be my actor ID. Always use name of when you're referring to stuff that already exists in your code. You know this, right? So this should work. No, it doesn't. Must have. Oh, did I not fully stop the run? Was that maybe the problem? This should now be okay. It's still crashing. That's cool. The last demo before lunch goes wrong. Has one, with many, foreign key, has principal key, has key. Yeah. Actor was in movies, doesn't have a foreign key. Anybody have a clue? No. Dylan was right. This should have been video. Damn it. Somebody said maybe. Excuse me? No, I should not have to do that. So has many with many. That is exactly what I had in my demo. Using entity. I give that a name. Yes. I have a left relation. That does a has one type of movie. Did I maybe? I think I may have to swap these. I think I may have to swap the left and the right. I think that is probably the problem. Because I'm mapping from the movie, which means that movie is left and movie is not right. So and that was it. Okay. Whew. Yeah. So everything went right. I should actually, when I refresh that table should become cast with its primary key, foreign key fields. And that is how we do the many-to-many, right? 3 minutes before lunch, I would have loved to do more demos, but you will have to come to the next iteration of this talk and just vote for different ones. And I'm not sure I'll ever do this again. This is stressful, live coding. But again, I do want to round out with, yeah, that was your nap time. Which one was fake? Oh, I'm still in magnifier mode. Let me first get rid. So which one was, can you shout? Which one was the fake one? What?
DB context without DB sets?
DB context without DB sets? No, you can actually do that. It's really fun. We even did some of it in the workshop yesterday. The one that was fake was double databases. Obviously, how can you join across multiple database engines? This will never happen. It's technically not possible, but I thought it was a fun idea to throw that in there, which meant you won twice. You didn't interrupt my talk with the alarms. You also didn't vote for the one that was obviously fake. It was a pleasure to be here. I hope you enjoy the rest of your conference. So I hope you walk away learning something. I still think EF Core is awesome. It is getting more awesome with every release. It's also getting faster with every release, which means you have less and less reasons to use all the lesser ORMs, right? This is my Twitter handle and my ICQ number, and I'm very sad to say I've been making this joke for 5 years, and this will be the last conference where I'm able to do it, because ICQ, although it's still active today and you can message me on the app, will shut down later this month. It's a sad time. Teenage me loved ICQ a lot to talk to strangers around the globe. I now go to conferences to do the same thing. So if you want to come up this week and talk to me, please do. I'll be here all week. Thank you so much.